So good morning, all of you.
Good morning, ma'am.
Morning, ma'am.
Yeah,
Good
good
morning, ma'am.
morning. Just to give me 1 minute, I
Good morning, ma'am.
good morning, everyone. So enjoyed 3 days mini vacation.
Yes, ma'am.
Yeah, so back to work. Submissions आएंगे, फिर additional टेस्ट होगी. I think we were at this slide absorption of sound. We have done this. Echo और reverberation हो गया है, right? Can anyone confirm, please? We have done reverberation. We have done this definition also, absorption of sound.
Yes, ma'am.
Okay, thank you. I need to start with Sabine's formula, right?
Yes, ma'am.
Right. Okay. ठीक है, चलो, thank you. So see, in the previous class, what we have seen is some of the basic properties of sound. Then two different types of sound waves, longitudinal sound waves and the transverse sound. Characteristics of the sound like pitch, timbre and loudness. Formula of the loudness level, that is I is equal to IL. Sometimes it is represented as L, or IL is equal to 10 log I1 upon I0. And then reverberation, echo. I would say that reverberation is the persistence of the sound after switching off the source of sound. Okay, जितने time तक you can listen to the sound waves, though the source of sound is switched off, that time we tell as a reverberation time. So the reverberation, now what the next thing we need to derive to see is we wanted to see the formula for the reverberation time, which is denoted by capital T. Okay, this time, reverberation time, it plays an important role in deciding the acoustics of an auditorium. Yeah, acoustics of a given hall. Right. So whenever these auditoriums are constructed, the reverberation time is taken into considerations. Right. The reverberation time has to be maintained at an optimum level. ज्यादा भी नहीं होना चाहिए, कम भी नहीं होना चाहिए, right? If your reverberation time is more, ज्यादा है, तो क्या होगा? In that case, there will be the multiple reflections, and because of the multiple reflections, there will be the interference of the sound waves, and the quality of the sound waves will not be proper, right? There will be the degradation of the sound waves. Now, what happens if your sound waves is very low? If the reverberation time is very low, then if you just think in the other way, that means there will be no reflection of the sound, right? And if there is no reflection of the sound, then there is a possibility that the audience may not hear to the sound waves that are produced by the source, right? So that kind of condition, when your reverberation time is very low, it is beyond the optimum level, then that room we tell as a dead room. What do you mean by a dead room? In a dead room, the reverberation time will be very low. So in that case, there will be no reflection of the sound waves, and due to which the audience may not listen to the sound waves, yet they may not hear to the sound waves that are produced, right? So, as I told you, during the construction of the auditorium, the acoustics is taken into consideration, right? So, for that, Sabine has derived a very good formula, a well-known formula, a famous formula known as an Sabine's formula, right? And this theory is known as a reverberation theory. What is the equation? What was the formula that he has derived is capital T is equal to 0.161 V upon capital A. In some of the books, it is written as 0.167. Okay, so you can write N. Now, what is capital V? It is the volume of the auditorium, volume of the on. A is the total absorption coefficient. Capital A is known as a total absorption coefficient. And I can write capital A as sigma As. Sigma As is also known as a total absorption coefficient. I will explain you what is this sigma As and what is capital A. Okay, I will explain you, though the theory is not there, derivation, but I will explain you why I have written sigma As. What is A? Small a is the absorption coefficient. Okay, different material have the different absorption coefficient. So small a is the absorption coefficient. S is the surface area. I'm not specifying that it is the surface area of the hall, yeah, surface area of any. This has to be small s, sigma As, right? I will come to this point when I just discuss the theory, but this is the equation that we will be using for solving the sums. 0.161V upon A, where A is sigma As. Now, before deriving the theory, Sabine has done certain assumptions, right? So Sabine assumed certain things before deriving the theory of reverberation, yeah, reverberation theory. The first thing he assumed was the volume is very large so that there is a uniform distribution of the sound energy. This theory is applicable for the in the case of a large volume of building. छोटा सा room है, right? So for the small room, we cannot apply this theory. That is a drawback of this theory. वो drawback overcome हुआ था by a scientist named Ahrens, right? It is known as an Ahrens equation. So, but we are not going to see that. But that is the drawback. We can apply the Sabine's theory for a room of very large volume. So first assumption he made was there is a uniform distribution of the sound energy, right? So in a given auditorium, wherever we go, the sound energy remains same. Second thing that he assumed was the absorption of the sound waves by the air is zero. That means the particles of the medium do not absorb the sound energy. That is not possible, right? Whenever there is a propagation of the sound waves, you must have studied, there is the absorption of the sound waves by the medium in which they are traveling. Complete mass energy transfer nahi hoga, right? Some of the energy will be wasted by during absorption, yet during the transport. But Sabine has assumed that the absorption by air is neglected. Matlab particles of the medium do not absorb the sound waves. Third thing is standing wave formation is neglected. Means there is no interference of the sound waves. See, in a given auditorium, whenever the sound waves are produced, there will be the reflection of the sound waves and also the propagation. So there are chances of the interference. But he has assumed that there is no standing wave, or there is no interference. The next assumption is sound travels in all direction uniformly, right? Matlab he has assumed that a source is hanging somewhere at the center of a auditorium and the sound travels uniformly in all the directions, right? With these assumptions, he has derived the theory. Now, what he has assumed, if you see this figure, before this figure, let us say that I am having a hall, I am having an auditorium, right? Let me assume any one wall of an auditorium, right? Now, on that wall, I will be having window, a simple like room up assume, right? So inside the room, I'm just considering a wall. Okay. So on that wall, ऐसा नहीं है कि पूरी wall जो है वो cement की ही होगी, right? Why I'm telling this? Because a different material has different absorption coefficient, right? So on an assumed wall, I will be having some of the portion made up of cement, right? Concrete जो भी है. Then I'll be having a window also. ऐसा तो नहीं है ना कि चारों के चारों जो walls है वो ऐसे ही होगी. So I'll be having a window, right? Now that window can be made up of, it consists of wood, right? Wood होगा, glass होगा, and it may have some aluminium material also, aluminium या iron material. Grill होगी window के अंदर, so that may be made up of steel या iron या aluminium, right? So window itself consists of different types of material, which different absorption coefficient. Let us assume wood or this glass here. So glass will be having some absorption coefficient, wood will be having some absorption coefficient, फिर कहीं पे cupboards होंगे तो उसके ऊपर सनमाइका होंगे, right? Coating होगा, so that will be having some different absorption coefficient. Some photo frames will be there with some different absorption coefficient. Switchboards will be there, which will be made up of 2 or 3 different types of material. So they will be having the different absorption coefficient. So for applying the Sabai's formula, what will be done is, suppose window. Okay, so window is having a glass. So I'll take a surface area. I'll calculate the surface area of the glass. Okay, let us say S1. उसका absorption coefficient A1. Right? So जितने भी glass के surface है assume wall पे, उसका absorption coefficient होगा A1 S1. Okay. उसी तरह wood, let us say उसका surface area S2 है और absorption coefficient A2 है. Right? So for that, what will be the total absorption coefficient? जितना भी जो भी material wall पे wood का है, so that will be A2S2. Hello? उसी तरह सीमेंट के लिए A3S3, राइट? उसी तरह कोई दूसरा मटेरियल है प्लास्टिक का A4S4, right? Then what I will do, after finding the individual absorption coefficient, I will find the total absorption coefficient. कैसे find करूंगी? I will take the summation of all the things. Summation of AS, मतलब A1 S1 plus A2 S2 plus A3 S3 up to A1 AN S1. So that will give me the total absorption coefficient capital A, right? So similarly, what Sabine has done is in the figure, AB is a wall. On that wall, he has taken a small surface area ds, right? On this wall AB, he took the small surface area ds, which is absorbing the sound energy coming from the source somewhere lying on this dome, right? ds है और surrounding that he has assumed a semicircle, एक dome जैसा assume किया है. वो डॉम के ऊपर कहीं सोर्स है which is emitting the sound energy, and that sound energy is falling on this ds, right? So what he did is, by applying the polar coordinates, he derived the energy absorbed by this surface area ds. Okay, कोई कोई ये डॉम के ऊपर कहीं पे भी सोर्स रखा हुआ है, पोलर कोऑर्डिनेट्स अप्लाई किए r theta phi, right? And then after he calculate the energy falling on this surface. From that he derived the energy falling on the wall AB. उसमें से उसने energy density derive की. Okay, formula derive की energy density. Then after finding the energy density, what he did was the decay of the sound wave. क्योंकि देखो, whenever the sound waves propagate ना, slowly उसका amplitude कम होता है, right? So decay of the sound waves and the build-up of the sound waves, they were calculated by him. Okay, and then after finally the reverberation time, this formula of capital T was derived. Capital T is equal to 0.161B upon A, right? Where A I will be telling as a total absorption coefficient. Somewhere in the numerical you will also be asked to find the average absorption coefficient, right? So I have given the formula for finding the average absorption coefficient A as A1 S1 plus A2 S2 plus A3 S3 upon S1 plus S2 plus S3, where this S1 S2 S3 are the surface areas of the different types of material that are there on the wall, right? So we'll be using, in short, we'll be using these two formulas, first and the last one, while doing the sums. Okay. Then after, one more thing is there, one more topic is there, which I told you is a kind of self-study question, that is the parameter that affects the acoustics of an auditorium. Okay, what are the parameters? Explain the parameters that affect the acoustics of a given building, right? Or a given auditorium. So among them, the first parameter is volume, the volume of a room, right? The volume of an auditorium. Let me write in short form V. Second parameter that affect is the shape. Okay, second parameter that affect the acoustics is shape. The third parameter that affect the acoustics is the absorbing material. I would tell it as an acoustics material. We'll be discussing all these things. Okay, though it is a kind of self-study question, but I would like to discuss this. The acoustical material, right? Now volume. 3 minute પછી. Right? Now volume. Now how the volume affect the acoustic? See, let us say that we have an auditorium with a capacity of say 250 audience, right? In our university, we are having a C auditorium, C block make auditorium, right? It is having a capacity of 230, 250 audience. Now, if there are 230 or 250 audience, then the sound system, the sound which is emitted by the source, कोई भी event है, right? Suppose a singer is singing, right? So the sound will be very clear, right? In Nirma, we have number of events when we were having these offline classes. Okay, और उसमें भी ये दिसंबर जनवरी में तो बहुत सारी events आती थी. Okay, so what happens if any XYZ famous singer is coming, na, then the auditorium will be full. Instead of 250, I think 300, 350, 400 students used to sit in an auditorium. Chairs पे तो बैठते हैं लेकिन साइड में 3 rows है, right? वहां पे 2-2 लोग बैठ जाते हैं. तो पूरा ऑडिटोरियम आगे भी बैठते हैं. ओके स्टूडेंट्स, सो पूरा ऑडिटोरियम जो है वो फुल हो जाता है, राइट? इट हैज अ कैपेसिटी ऑफ 230 या उसका वॉल्यूम इतना ही है कि वहां पे 250 ऑडियंस ही बैठ सकते हैं. बट इंस्टेड ऑफ दैट से 500 ऑडियंस आर सिटिंग, सो द एब्जॉर्प्शन जो है वो ज्यादा होगा, राइट? सो ड्यू टू दैट जो पीछे लोग बैठे उनको आवाज क्लियर नहीं आएगी. ओके, सो दिस इज हाउ द वॉल्यूम अफेक्ट्स. जितना वॉल्यूम है, जितनी कैपेसिटी है, the number of audience must be as per the capacity only. If the audience are more, then what happens? There will be the absorption. But उसी तरह sometimes it is happening in the class. Okay, last class में जो lectures होते हैं ना, जब term end होने होती है, last week जब review आ जाता है तब, so 70-80 की class में सिर्फ 4-5 students ही बैठे होते हैं. Okay, and the faculty used to teach. So in that case, what happens? The room is empty. So there will be more reflection of sound. So this we have experienced. Okay. So in that case, the echoes will be produced. आवाज बहुत मतलब the intensity of the sound will be more in that case. So the audience, the number of audience must be as per the volume of a given room. उसी तरह shape. Okay, the shape of an auditorium या hall generally if you have seen they are rectangular cuboid shape के होते हैं या sometimes square, right? But it is never of the shape of a dome. Dome जैसा नहीं होता, वो sphere जैसा. Okay, जो observatory होती है वैसा, right? So if the auditorium is of the shape of a dome, what happens? There will be the multiple reflections of the sound waves and the echoes will be produced, right? The third thing is acoustical materials that are present inside the auditorium. Acoustical material मतलब curtain, साउंड एब्जॉर्बिंग मटेरियल जैसे सिरामिक पोरस मटेरियल होते हैं, राइट? फ्लोरिंग number of chairs, all these things affects the acoustics of a building. Generally, see, in a given auditorium ना, if we talk about of auditorium only, जो स्टेज होता है ना, स्टेज के पास जो वॉल होती है ना वो पैरेलल नहीं होती. ओके, they are not generally inclined at certain angle. पैरेलल होगी तो क्या होगा? वो रिफ्लेक्शन वही स्टेज पे ही होगा और क्वालिटी डिग्रेड होगी, राइट? इसीलिए जो वॉल्स है ना स्टेज के पास की, यू कैन वो डाइवर्जेंट पोजीशन में वॉल्स रखते हैं, राइट? सो अ स्मॉल टॉपिक व्हिच कैन बी आस्क्ड एज अ शॉर्ट नोट, explain the factors, the parameters that affects the acoustics of an building.
मैम
Any question? Yes, बोलो.
मैम टेम्परेचर पे डिपेंड रहेगा ये?
इतना तो नहीं रहेगा टेम्परेचर पे, क्योंकि मतलब वैसे तो रहना चाहिए, लेकिन कभी भी व्हेन साउंड प्रोड्यूस होता है तो टेम्परेचर तो कोई एक एनवायरनमेंट के लिए जनरली कांस्टेंट ही रहता है. ओके, इतना डिफरेंस, इतना वेरिएशन नहीं आता कि इतना नहीं होने अफेक्ट करेगा अगर आप फिजिक्स साइड देखो तो, बट इट्स नॉट गोइंग टू मेक दैट डिफरेंस. ठीक है, बट साउंड प्रूफ रूम रखते हैं बस, दैट्स ऑल. अगर टेम्परेचर हाई होगा, लो करके भी कितना करोगे आप? 18 मैक्सिमम, उससे लो तो आप जाने वाले नहीं हो. सो दैट इज नॉट गोइंग टू अफेक्ट. ओके, एनी अदर क्वेश्चन?
No, ma'am.
हाँ, okay. So let us go to the second part. Very easy. Ultrasonic waves. Okay. So we know that the sound waves of a frequency more than the 20 kilohertz, they are known as an ultrasonic waves. Right? So these are the few properties of the sound waves. They ultrasonic waves. Ultrasonic waves are not audible by us. That we know, right? But they have this small wavelength. ના ના વાંધો નહીં, તમે ના હા એમાં જ કરવાનું. They have the small wavelength, and as they have the small wavelength, they have the high penetrating power. They can they are unidirectional, matlab highly directional beam, high energy, speed of propagation increases with the increase in the frequency, right? These are the few properties of the sound waves, which you know, right? I am not going to discuss this. This is just a kind of revision for you. Now, this is our part, how to generate the ultrasonic waves, right? Based on the frequency and power, there are two generators which are used for generating the ultrasonic waves, mechanical generator and the electrical generator, right? And we are not going to see the mechanical generator, matlab as per our syllabus, we'll be seeing the electrical generator only. So there are two types of electrical generator, magnetostriction generator and the piezoelectric generator, right? Which we are going to see as per our syllabus. That is the magnetostriction effect and the piezoelectric effect. So in short, we will be generating the ultrasonic waves by two methods, that is the magnetostriction method and the piezoelectric method. Piezoelectric method you must have seen somewhere while doing the practical of this ultrasonic interferometer. But magnetostriction method you must not have seen. So one by one we'll be seeing both the methods. Let me start with the magnetostriction method. If you see in the figure, we have the two magnets, a north pole and a south pole, and a ferromagnetic material converted in the form of a rod is to be kept in between the magnetic field. Now the magnetic lines of force are parallel to the ferromagnetic material. Okay, so ferromagnetic material matlab nickel ya ferrite material lo, convert it in the form of a rod and keep that ferromagnetic material in between the two magnetic poles. Now, what you will do is when the direction of the magnetic field is changed, right? When we keep this ferromagnetic material in an alternating magnetic field, मतलब north to south होता है, south north, ऐसे north south है, no north south south north, ऐसे magnetic poles change होते हैं, right? You are changing the direction of the magnetic field. Fine. So when we keep the ferromagnetic material in an alternating magnetic field, the rod starts vibrating. There will be the vibration of the rod along the direction of the magnetic field, right? And when the frequency of the vibration of the rod, that is the ferromagnetic material, is equal to the frequency with which the magnetic poles are changing, right? Frequency with which the poles change, matlab ki applied frequency. At that time, because of the resonance, the ultrasonic waves will be produced, right? I am repeating as per the definition. When a ferromagnetic material in the form of a rod is subjected to an alternating magnetic field, changing magnetic field parallel to its length, the rod undergoes contractions and expansion. मतलब vibration होगा, right? Vibration की वजह से ऐसा लगता है कि there is a contraction and expansion of the ferromagnetic material, which is equal to the frequency of the applied field. At that time, the ultrasonic waves are produced. Okay, now the question is, see, when I keep this material, when I keep this ferromagnetic material, ferromagnetic rod in an changing magnetic field, in an alternating magnetic field, the rod starts vibrating, Now, what is the reason for the vibration of a rod? Can anyone tell me why the rod vibrates? Yes, right, right. It, yeah, change in the direction of the magnetic dipoles, right? Because you are changing the magnetic field. So if we change the magnetic field, the direction of the magnetic dipoles will also change, and because of which the material, the rod starts vibrating, right? And when the vibration frequency of the vibration of rod is equal to the applied frequency, the ultrasonic waves are produced. Now, what the frequency of the vibration of a rod is given by this equation: 1 upon 2L under root E by rho. L is the length of the rod, E is the elastic modulus, and rho is the density of the material that you have taken. Right. Now, what are the advantages? I will show you the circuit. It is very simple. A tank circuit is used for producing the ultrasonic waves. So design of the oscillator is simple and production cost is low. You require a triode and a capacitor and the inductor only along with the ferromagnetic material. So it's very cheap. The frequencies in the range of 100 hertz to 3000 kilohertz can be produced with the help of the magnetostriction method. The demerits, if we want to go for a higher frequency, it's not possible. Okay. Second thing is we are using a ferromagnetic material. So when you use a ferromagnetic material, there will be the hysteresis losses, eddy current losses will also be there, and the frequency of oscillation depends on the temperature. Okay, so high temperature pay, the frequency of oscillation will be more, right? So these are the few drawbacks. ऐसे कुछ circuit है magnetostriction effect के लिए, right? AB is a ferromagnetic material. L1 and L2 are the inductors. They act as a magnet. So we'll be applying the AC voltage to each, and due to which, because of the AC voltage, there will be the change in the direction of the magnetic field, and it produces the ultrasonic waves. Right. So what you have to write is what is the magnetostriction method, why the rod vibrates, what are the advantages, and what are the disadvantages of the method. Is it fine? Any questions from this topic? Applied field, yes. So any questions? If no, then I will move further. बहुत छोटा चैप्टर है. Piezoelectric effect. लैब में शायद some of you must have studied this piezoelectric effect. See, the few crystal, few material like quartz, tourmaline, they are the piezoelectric material. Okay, I have a lump of quartz, yeah, lump of tourmaline, then they will not act as a piezoelectric material. I have to cut it in such a manner that it behaves as a piezoelectric material. Let me start with some examples. You might have heard about the shoes with which you can charge the mobile phones while walking. खड़े खड़े आप लोग चार्जिंग नहीं कर सकते. You need to walk. So what will be there in that shoes at the foot, you will be having a small chip of piezoelectric material. Quartz की या piezoelectric crystal की एक chip होगी, right? Now what you are doing, you are walking, right? So when you walk, you are applying the force on the crystal, and due to that applied force, the electricity will be generated. मतलब mechanical energy converted into the electrical energy. So the piezoelectric effect says that if I have a piezo crystal, generally piezo crystal is represented with an hexagonal shape, and I am applying the force on this crystal in the opposite direction. It can be a compressive straight, yeah, stretching wala stress. So suppose if I am applying the force on this piezoelectric crystal, so at that time the opposite charges will be developed on the two faces of the crystal. Okay, एक side positive होगा, एक side negative होगा. So this effect is known as an piezoelectric effect, right? So in our case also, what happens when in the case of the shoes, when we walk, no, we are applying the force, we are doing the mechanical work on the crystal, right? So when the mechanical work is done on the crystal, it converts the mechanical energy to electrical energy and it generates some charges, right? So इतने भी चार्ज जनरेट नहीं होते कि with that you can run a fan या ऐसे, you can at least generate a 5 volt या 6 volt with the help of this piezoelectric effect, right? So this is one example. Another example is you might have heard about the, matlab, yeah, you must have seen the lighters with which the cigarettes are blown, right? Cigarette वो जलाने का जो lighter होता है, there also you have a piezo crystal. Fine. So when you apply the force, na, when you apply the force on that crystal, the electricity or spark is generated, and with that spark you can glow the cigarette, right? Similarly, in on the stage, dance stage, right? On the dance stage, there will be the piezo crystal. So when the dancer dance, no, as per the force applied, there will be the lightning and the light will glow. Okay. So these are the few examples where this piezoelectric effect is employed, right? So the piezoelectric effect says that when the pressure is applied to one pair of opposite faces of a crystal, equal and opposite charges appeared across its other faces. This phenomenon is known as piezoelectric effect. Now here we are not going to use the piezoelectric effect for generating the electricity, for generating the ultrasonic waves. We will be using the reverse piezoelectric effect to generate the ultrasonic waves, right? Now what is the reverse piezoelectric effect? यहाँ पे जगह नहीं है, I have to use this space only. In the case of the reverse piezoelectric effect, we will be applying the electrical energy and converting the electrical energy to mechanical energy, right? So a piezoelectric crystal is there, and we'll be keeping the piezoelectric crystal between the two conducting plate, and this conducting plate will be connected with the oscillator. Yeah, you can say that generator which generates the constant frequency. जो आपने इसमें किया होगा अल्ट्रासोनिक इंटरफेरोमीटर में, राइट? जहां से आप वो करंट वेरी करते थे. Fine. So this is our oscillator which generates the constant frequency. Let us say in your practical you must have taken the frequency of 2 megahertz. You can give the direct AC voltage also, but in that case what happens, your frequency may not be constant. So frequency constant लाने के लिए we are using this oscillator to generate the electricity. Now what happens, I am connecting this conducting plate with this oscillator, right? So as soon as I switch on the oscillator, एक plate जो है वो positive हो जाएगी, another plate will be negative. Now there will be some free charge carriers inside the crystal. So due to that, what happens, the free charge carriers, they tend to move towards the opposite plates. मतलब negative charges जो है, they will move towards the positive plate, and the positive charges tends to move towards the negative plate. Now here we are giving the AC voltage, right? Now by the time the charge carriers moves out of the crystal, ये plate की जो polarity है वो change हो जाएगी. Positive plate will become negative and negative plate becomes positive. So what happens? Charges जो है वो repel होंगे. Okay, and again the same thing, opposite positive charges, now they will move towards the upper plate and negative charges moves towards the lower plate. Again there will be the reversal of the charges on the plates, right? So due to this, the charge carriers inside the crystal, this starts vibrating. Okay, वो jumping करने लगेंगे. Okay, and due to which the crystal starts vibration. Okay, there will be the lattice vibrations. इतने भी vibrations नहीं होंगे कि you will be able to see with your eye. Okay, crystal में, but there will be they are known as lattice vibrations, right? So there will be the lattice vibration which vibrates the crystal. So when the frequency of the vibration of the crystal is equal to the applied frequency 2 megahertz, जब आपका क्योंकि कितनी frequency हमने apply की है 2 megahertz जितनी. Okay, you can change the frequency with the help of the oscillator, right? So when this crystal vibrates with the 2 megahertz frequency, resonance will produce the ultrasonic waves from the sides, right? So this effect is known as a reverse piezoelectric effect. We are applying the electrical energy and converting the electrical energy to mechanical energy. Fine. So what it says, I need to close this. The piezoelectric method of producing the ultrasonic waves is based on the principle of the inverse piezoelectric effect. If you apply an alternating voltage to the pair of the opposite sides of the crystal, there will be the mechanical contraction and expansions inside the crystals, and due to which the crystal starts vibrating. And when both the frequency matches, we get the ultrasonic waves. Fine. Any question from this topic, piezoelectric method? Any questions? No? Okay, fine. The next is the practical that you have done. Ultrasonic waves, yeah, acoustics, grating. I think 10 minutes may I will not be able to complete, but then also let me try. Determination of the ultrasonic waves. It is also known as an acoustics grating. Right? So before going to the principle, let me explain you the figure. Then we will be going through for the principle. Now see, if you can see in the figure, you can see some horizontal kind of thing, right? So this is your transparent, you can say cylinder. This is your cylinder. Okay. And so this is the transparent cylinder and it is filled with some transparent liquid, say water. So I have a cylinder filled with water. Now at the bottom we have a piezoelectric generator. Okay, यहाँ से ultrasonic waves generate होते हैं and we are using a piezoelectric generator. You can see यहाँ पे लिखा है quartz crystal, right? So from here we are generating the ultrasonic waves और to radio oscillator मतलब वो जो oscillator है उसके साथ इसको connect किया है, right? At top you have a reflector. आप लोगों ने practical किया होगा, right? वो reflector was connected with the micrometer screw and you were changing the height of the liquid column. यहाँ पे the height of the liquid column has to be constant. We are not going to change the height of the liquid column, right? So now I have a liquid column filled with water, right? And I will start the oscillator. Okay, so when the oscillator is switched on, the ultrasonic waves will be generated and that ultrasonic waves will pass through the liquid column. Fine. Now, when the ultrasonic waves pass through the liquid column, they will move towards the reflector and from the reflector, it will be, the ultrasonic waves will be reflected. Okay, I am repeating. I have a liquid column. The ultrasonic waves are allowed to pass through the liquid column, right? So when they pass through move through the liquid column, they will be reflected from the reflector. Right. So what happens? I will be having the waves moving upward and the waves that are coming downward. Right. So due to which there will be the interference of the waves, and as the height is fixed, the standing wave pattern will be produced inside the liquid column. Right. I will get the standing wave pattern inside the liquid column. Matlab interference. Now, if I am having an interference, then there will be a constructive interference and the destructive interference, right? So there will be the constructive and the destructive interference inside the liquid column, right? So what happens? Due to the interference, a specific kind of pattern will be formed inside the liquid. जहां पे कंस्ट्रक्टिव इंटरफियरेंस होगा से फॉर एग्जांपल यहाँ पे देयर विल बी द कंप्रेशन एंड रेडिफेक्शन राइट सो यहाँ पे देयर विल बी द रेडिफेक्शन so that I will be getting the constructive interference. The place where there is a destructive interference, the particles of liquid will be compressed. Okay, so compression, then a rarefaction, compression, and a rarefaction. Right? जहाँ पे constructive interference होगा, there the particles will be far away from each other. Where there is a destructive interference, there will be the compression of the particle. Right? So a specific kind of pattern will be created inside the liquid column. And this ये जो है यहाँ से यहाँ तक का, it will give me lambda. Okay, ये एक wavelength होगी, and this will be ये जो है that will be equal to lambda by 2. So if I assume this as d, I can write d equal to lambda by 2. Okay, I am repeating. I have a liquid column filled with water, say for example. At the bottom, there will be an piezoelectric generator which generates the ultrasonic waves. They pass through the liquid, get reflected by the reflector, due to which there will be the interference, which produces the standing wave pattern. Right? So the place where there is a constructive interference, the particles will be far away from each other. Where there is a destructive interference, compression hoga, right? Particles will be very near to each other. So a specific kind of sequence will be formed inside this liquid column, right? Now, when once I get this standing wave pattern, I will take a monochromatic light source like sodium lamp, allow the light to fall on this liquid column at 90 degrees. Right? So when the light they fall on this liquid column where the standing wave pattern is formed, there will be the diffraction of the light waves, and the other end on the screen I'll be getting the diffraction pattern. Now क्यों diffraction? See, यहाँ पे compression हुआ है, right? Temporary आपके जो particles है वो compress हुए हैं, okay? और यहाँ पे space है, so slit जैसा कुछ create होगा, right? जैसे नहीं, if you just assume two doors of window या two doors of your door, दो डोर के बीच में कुछ एक स्लिट जैसा होगा जहां से you must have seen the light coming. So ऐसे स्लिट जैसा क्रिएट होगा, right? From where you have the diffraction of light. So यहाँ पे भी you will be having the number of slits in the liquid column. जहाँ पे rarefaction होगा, there you will be having the number of slits, right? So this will diffract the light, and I will get the diffraction pattern on the other side of the you can see that screen. So ऐसा कुछ होता है, देखो. This is a practical in MSc. This is your liquid column. Piezoelectric oscillator यहाँ है, reflector है. There is a standing wave pattern, and on the screen of the CRO you can see the zeroth order maxima with the first, second, third order diffraction pattern आपको मिलेगा, right? So what it says, let us go to the principle. When an ultrasonic waves are passed through transparent liquid medium in a container, the waves get reflected. The reflected and the direct wave they superimpose on each other to give the standing wave pattern, yeah, stationary wave pattern. These waves give a rise of the periodic variation in the density of a liquid, right? A temporary liquid की जो density है वो चेंज हो जाएगी। जहां पे कंस्ट्रक्टिव इंटरफियरेंस है वहां पे डेंसिटी कम होगी, फिर कंप्रेस हुआ है वहां पे डेंसिटी ज्यादा कम ऐसे पीरियोडिक वेरिएशन होगा, राइट? एंड दिस चेंज विल लीड टू द चेंज इन द रिफ्रैक्टिव इंडेक्स ऑफ द लिक्विड. The density of the liquid would be maximum at the nodal plane and the minimum at the antinodal plane, right? So such a liquid column when they are imposed, yeah, when they are subjected to the ultrasonic waves, they behave like a grating. Grating मतलब एक plane है, वो plane के अंदर छोटी-छोटी जो slits होती है, right? It is known as a grating, right? So under this condition, as I told you, when the light wave falls at 90 degree, there will be the diffraction of the light waves, and due to the diffraction, you will get the diffraction pattern. So your liquid column acts as a grating to have the diffraction of the light waves, right? One more figure is there, that's fine. So now we know what is Bragg's law. D sin theta is equal to n lambda. Okay. D is the spacing. Spacing मतलब as I have written here, ये जो lambda by 2 जितना, okay, spacing between of the grating, ये भी D होगा, white वाला जो है वो भी D होगा, and n theta is find the angle, lambda is the wavelength of the ultrasonic waves that is falling. Now in our case, what is D? Can I write it as lambda by 2? D is equal to lambda by 2. So यहाँ पे मैं D की वैल्यू सब्स्टिट्यूट करूंगी lambda by 2. So lambda by 2 sin theta is equal to n lambda. Now मैंने lambda u लिखा है. क्यों? Because it is the wavelength of the ultrasonic waves. और ये lambda जो है n lambda वाला, it is the wavelength of the light that is falling on the liquid column, right? So if I write lambda u by 2 sin theta is equal to n lambda. So what can be lambda u? That is the wavelength of the ultrasonic light, 2 n lambda upon sin theta, right? So from this you can find the wavelength, or if you want to find the velocity, v is equal to f lambda, right? So this method is useful for measuring the velocity. हमने practical किया है ultrasonic interferometer में, and we have calculated the velocity and also the wavelength of the ultrasonic waves. So ये बाकी का I will take later on. थोड़ा ही बाकी रहा है. Any questions from this topic? No? ठीक है, fine. Okay then, thank you.
Thank you, ma'am.
Yeah, welcome.
Thank you, ma'am.
Thank you, ma'am.
Yes.